Now let's implement the dynamic philosopher solution using synchronize. So for this, let's first create a new class, and then the class name is dynamic philosopher. And synchronized. So let's create public static void main. And also for this solution, we'll be implementing a class philosopher that will be implementing runnable. So let's implement that class philosopher implements runnable. It's complaining about the implements method, so click here and run. Now philosopher has two states, and the states are left fork and right fork. So private object left fork and private object right fork. And now let's implement a constructor public philosopher and then object left fork and object right fork. And this dot left fork equal to left fork, and this dot right fork is equal to right fork. And inside the run method, we'll be going for a loop indefinitely, so that this solution will continue on executing, where philosophers will be continuing on in the loop of eating and thinking and eating again. So while true, let's implement a solution where we'll be mimicking the eating. So it is basically do work or maybe eating. So eating, and here what we'll be doing is that we will be getting the system.current_time.millisecond and plus, and here thinking. So this is the first time we are passing on this method eating system.current_time.millisecond and also concatenating it with thinking, because at this point the philosopher is thinking. But then let's implement the solution. Let's implement this method eating generate or generate method. Here inside this method, first of all, let's print out the name of the thread. So thread dot current thread dot get name plus and plus s. So here it will first put the message, the thread.current thread.get name, and then the timestamp, and then philosopher, and then thinking. So this will give us the philosopher 1 and current timestamp, and then thinking. Now let's have this thread to sleep, and thread.sleep, and we'll be sleeping this thread for random number, because it may take different times for different philosopher to eat. So that's why we'll be implementing this using a random number. So here we'll be casting it with integer and then math dot random multiplied by 100. and then add exception handler. Or maybe just do that try catch directly over here. Now let's synchronize on the left object first, which is a left fork, and do an eating. Actually, we should be calling this do work because we'll be using the same method for thinking and eating. So let's call this do work. So here do work and system dot current time millisecond and plus a message here picked up left fork. So when he got the lock on the left fork, then it means that he picked up the left fork. So that's what we are printing as a message. Okay. Now inside this, we'll be synchronizing on the right fork. And again, do work and system dot out system dot current time millisecond plus here picked up right fork and eating. And now do work a message with system dot current time millisecond, and the message is, because it's out of the synchronized loop, so the message which we will be putting here is that putting down or put down right fork. Now at the end of this, we'll be putting the message system dot current time millisecond plus put down left fork and back to thinking. So that's all for our implementation for the Philosopher class. Now let's go to our static void main class, and inside the static void main class, what we'll be doing is that we'll be creating 5 instances of Philosopher and we'll be putting into a array list of philosophers. So philosophers array list philosophers is equal to new philosophers. So we are creating a array of 5 philosophers. And we have 5 forks, so we'll be creating 5 forks as object array, and this is forks is equal to new forks of 5, a new object of 5. Now let's instantiate those forks. So for this, what we'll be doing is that we'll be looping I is equal to 0, I is less than forks dot length and I plus plus, and we'll be instantiating the forks object. So forks of I is equal to new object. So we are just initializing the object using the for loop. Now let's initialize the philosopher also. for integer, because we have 5 philosophers, we just created the array, but then we need to initialize it. So for I is equal to 0, I is less than, spelling mistakes. Let me correct the, okay, it's not complaining about the spelling. Okay, I is less than philosophers dot length and I plus plus. So for philosopher, first object left fork is equal to forks of I. Okay, because we have to rotate all the forks inside the philosopher, because philosopher also have left fork and right fork. And object right fork is equal to forks of I plus 1 and then percentile forks dot length, because the fifth philosopher will also get the fifth philosopher has on the right side the fifth fork, but on his left side is the first fork. So that's why we have to do it with the mod operation, so that the right fork is assigned correctly. Now philosophers of I is equal to new philosopher and left fork and right fork. And thread T is equal to new thread. So we are starting all the philosophers thread. So philosophers of I, and the name of the thread is philosopher. Plus I plus 1 and T dot start. So that's all for the implementation. Let's go through the program again one more time. So we have created a class philosopher which has two objects, left fork and right fork, and we are running and synchronizing on the left fork first and then right fork afterwards. And then once they are done with the right fork and left fork, it means that they have eaten. And now over here we are initializing forks, 5 objects of fork, because we have 5 forks, and then we are initializing 5 philosophers and then assigning the forks to them. So left fork and right fork, and afterwards we are starting the thread. So we are starting 5 threads. Let's run this example. So you can see that it is going in loop. Stop it. Now let's go to the top. So philosopher 4, 3, 2, 1 and 5 are thinking. Philosopher 5 pick up the left fork, philosopher 1 pick up the left fork, and then you can see that here philosopher 3 is eating, then philosopher 1 is eating, philosopher 2 is eating. You can see that everybody is eating. So that's the implementation using synchronize keyword for the philosopher problem.